Our last speaker, Professor Bobbi Lowe. And I'll just run through Professor Lowe's history. Did her BA in Biology, Honours, University of Louisville. Where is that?
Louisville.
Kentucky.
Kentucky.
Then an MA in Evolutionary Zoology, 1964, University of Texas. Followed by a PhD, University of Texas, in Evolutionary Zoology, already focusing. Then postdoc, University of British Columbia. And now, since then, University of Michigan, Professor, School of Natural Resources and Environment, University of Michigan, in the Evolutionary and Behavioural Research Group, or is that a program? Or
It's a funny, informal group. Sometimes it's a department, sometimes it's just a group.
Great.
Very strange.
High-powered research group. And I should add that Bobbi Lowe is current president of the Human Behaviour and Evolution Society, which is a very important, probably the most important society for studying human evolutionary biology. And her talk today will be on the evolution of human sex differences and how this affects women's lives today. Very topical. Take it away.
Thank you, Frank. So Frank asked me to talk about the evolution of sex differences and about women's lives today. So I need a little information from you to start with. And I have to ask the men and the women separately. Of the men in this room, how many of you have children? 1, 2. So, of you men, you're younger than those guys. How old are you? Is it okay to ask? Yeah? 23? Good. Of the women, is that any man younger than 23 have a child that I missed? Okay. Of the women, how many of you have children? Yeah, right. Okay, how old are you? Uh-huh. How many women in this group are 23 or older? And you don't have kids, do you? Huh. I was 36 when I had my son. Women today tend to be delaying their fertility, and I think there's a story behind how that comes to be a sensible thing to do. And I think there's a story about how there may be hidden benefits and hidden costs to doing that. So I want to begin with the observation that is hardly startling, that around the world, in different societies, women's lives differ greatly. They differ in the total fertility. How many children do you have? One. And how many children do you have? 3? I have 1. Of the men, who has the most children? 3. You have 3. Anybody beat 3, Frank? Can you be? 5. Okay, you get the picture? But not only the total fertility, but the timing of fertility. If you and I each have 2 children, and you have your children at ages 16 and 18, and I have my children at 36 and 38, and our daughters do the same as us, you're having grandchildren when I'm having my children. So if you imagine that it matters whether we think about it or not, how your family lineage grows or shrinks and persists through time, the timing of your fertility is also biologically important. Today, there are many things that matter. If you work, you may delay fertility, and I do think there's an important story there. In traditional societies, the value of a man to a woman was his status or his power or his resources. But the value of a woman to a man was her fertility. Her reproductive value is what Fisher called it. And in fact, you can still see that in many bride price societies where the husband must pay so many cattle or so many goats, so many sheep for a bride. A 14-year-old woman is worth more cattle, other things being equal, than a 15-year-old woman. And a 15-year-old woman is worth more cattle than a 16-year-old woman. And I'm sorry, by the time you're 25, you're not worth any cattle, okay? But today, women are shifting. If you're only going to have 2 or 3 children, and if it's expensive to raise your children so they have a good chance at a good education, at good jobs, then perhaps it pays to wait a little and get resources yourself. So women have sort of a more mixed strategy in many societies today than was true in traditional ones. Across societies, how much voice women have in decisions not only in the family but in the social group and in governance, it differs. How many women, so is there a parliament? What proportion of the parliament is women? Less than 10%? Okay. Yes. Wait till you see the figures for the US. It's even worse. Okay. So partly, I'm going to argue that there are some problems that make it hard for women. Have you seen this before? The way I'm going to look at humans is a sort of odd way. I'm going to say, what would we predict if we didn't know anything except humans are a very smart, highly social primate. Most people who look at humans, not this group, are sort of like disconnected from the biology. Everybody who studies lizards understands that the successful lizards are the ones who eat, survive, reproduce. And we get to humans and we go, oh, what matters? Okay? I'm going to talk first about the basics. So it's a behavioral approach, a behavioral ecological approach, a sort of Darwinian look. And I'll look at the evolution of life histories, and that involves the evolution of sex differences, and then look at the way women's lives vary across traditional societies. Historical, I'll mostly talk 19th century European, and then modern post-industrial. I am just starting to try and look at women's lives in developing nations today. A first thing to remember is that even though we humans are complicated and we have things that matter to us that are far different from eat, survive, reproduce, nonetheless, the way we are, who we are, how tall we are, and so forth, comes from an interaction of 3 things. Natural selection, the fact that if the environment is very, very cold, you will have a different genetic component over time than if it's very, very hot, and so forth. What biologists call phylogenetic constraint. Now, it might be profitable to me if I could spend the winter at the bottom of a pond and do my oxygen exchange through my skin, right? A lot of frogs do this. I can't. I'm stuck being a mammal. That's what we call phylogenetic constraint. Some strategies are not available to you if you're a mammal versus a lizard versus a frog. And finally, the historical past. There are strategies that are very difficult to introduce because this little population has been isolated a long time and some variation has been lost. There are a lot of complexities, but I'm going to start with the simple stuff. In the very simplest of all possible models, there is some effort, calories you spend, risks that you take to get energy, and then you have to allocate that energy. You spend some on growing, or on regulating your temperature, which is less easy today than some days, right? That's self-investment, somatic effort, we call it. You can spend effort on reproduction. The point is that if you are this big and you're a mammal, there is a limit to how much energy you can process at any moment. So we become, this allocation problem becomes a zero-sum game, more properly a constant sum game. What you spend on yourself, you cannot spend the same energy at the same moment of production. Part of what I said a moment ago about women's lives, I think women, as female mammals, face harsher trade-offs here than do men in modern societies. If I don't make this clear later, stop me and ask, okay? Obviously, both reproduction and self-maintenance contribute to your fitness, to reproducing, to having grandchildren, to having your lineage go on. But you can't do everything maximally all the time. So here's the kind of thing that happens in human traditional societies. Take a man who's a Yanomamo chief. I'll show you a picture of a guy in a minute. The better his status, the more children he has. How much he puts into each child doesn't vary much with his status. So children's survivorship is mostly dependent on things other than the father's status or resources. So number of children is the best predictor of number of adult children. And all this stuff that's gray is complications that doesn't matter much, okay? Now there are trade-offs in reproduction. We said that if you have children at 16 and 18, you'll have grandchildren before I do. But there can be costs. There are trade-offs also in whether you reproduce early or late. My very first doctoral student had her first child when she was 17. She grew an inch and she got cavities in her teeth, and the child sort of sucked the calcium out of her. So if you reproduce very early, you may suffer a cost. It may cost you so much that you never reproduce again. If you wait a long time, your initial fecundity can be greater, okay? You can have more babies or bigger babies, but you have more chances to die before you get there. So if life is really uncertain, if I may die any minute, then I should mature as fast as I can and make those babies. And I should also make babies who don't take my care, right? Because then if I die, who will care for them? We've just wasted it. A maxim for all of you is never invest in dead babies, okay? Dead babies bring you no profit. So we do see these tendencies, and this is not in humans alone. This is across all sorts of species, that if life is dangerous, you will reproduce early. If life is safe, and especially if the environment is competitive for your children, you will wait longer, store more resources, and have offspring later. Now here is a whole bunch of different species. These have been logged and made almost metric free so that they can be compared, because, you know, voles live about a year. Chipmunks live 3 or 4 years. Hippopotamus live a lot longer. But as you see, the shorter your life expectancy, the earlier in your life expectancy you reproduce, okay? So when life is nasty, brutish, and short, reproduce early. Now humans are especially interesting in this way because once we compare impala, sort of an African antelope, to cottontail rabbits, to otters, to sheep, to little mice, I mean, you go, oh, but so much is different. But with humans, you can look inside the same species at environment and fertility patterns. But we are very strange primates. We are very weird. We are dependent on our mothers much longer than you would expect for a primate of our size, and we mature late. We're very social. This one is very hard for us to imagine today. Is anyone in this room part of an arranged marriage? Okay. So you consider it your right to date, to find somebody, to choose your own marital partner, right? In most traditional societies, women would not have that right. It's relatives, usually the father and male relatives, who make those decisions. In Romeo and Juliet, the argument was because Juliet at 14 was betrothed by her father to a middle-aged man, right? And he had the right to do that at that time. And part of the sociality is that others besides mother feed the child. And then we are really extraordinary in the amount of variation we have. The closest I can think of, have any of you seen the work on dunnocks? This is a British little brown bird. It looks like what we call an English sparrow. I don't know what you call it here, but it's throughout Europe. So in these little birds, you can have monogamous pairs. You can have a polyandrous trio where one female, two males. You can have polygynous systems with one male and two or three females. Mm-hmm. Thank you. I should have asked before. Yeah? Help me out on this as we go along, because there will be others that I won't know the right names for. Cool. So we humans have this huge variation, and even with that variation, we are still weird. So there is a cost to growing large, and people like Paul Harvey and others have done a lot of work to sort of regress things like age at maturity against size. And you go, okay, the bigger you are, the longer it takes. You can do this for many traits. When you do it, you can calculate this vertical line is what you would expect for humans given the size we are. Okay, so you find out that human babies are carried about 10% longer in utero than you would expect. Babies are about 38% bigger than you would expect. And in fact, a lot of the last part of pregnancy is just growing the size. Now, if we were typical primates for our size, when do you think we would wean our babies? Make a guess. Make a guess. The same? Okay. Anybody think longer or later? If we weaned our babies on the typical primate schedule, we would wean them at age 7. I don't know about the guys in the room, but the women ought to think about this. And our daughters would begin to have babies at age 8. So you see, the pace of our life is very different. We wean our babies years earlier than you would expect, but then our children stay dependent much longer. I mean, I don't know anybody who's had a child at age 8. They tell me that in some areas where there are a lot of estrogens in the food, that girls may start to menstruate at 8 in some societies now. But So we are very strange. And we live a lot longer. We live 83% longer than you would expect for our size. And our adult brain size is about 83% larger than you'd expect. All of this, people think, has to do with sociality. So here's an example. This is chimpanzees. Note, and chimpanzees are fairly typical among primates in that the first conception is about 10 to 15% along the lifespan. And there's gestation, then nursing, and then you wean the kid, and there's a period when you're not pregnant, you're not nursing, you're sort of catching up. And the last child is weaned very close to the end of the mother's life. Here are 3 human societies, the Kung from Africa, Hutterites, about which there's an amazing story. Hutterites are a religious group. They're intense agriculturalists for the most part, and demographers use them as sort of the natural fertility benchmark. Now, this begs the question of what's natural. It's really maximum fertility in a well-nourished population that doesn't use contraception. Okay, so you never find, notice, look at this, there's no time in between babies. And these are the women who, this is where the baby machine term got started. But among the Kung, children are weaned at 4. The interbirth interval is about 4 years. I worked on the sex life of long-dead Swedes. I know more about 19th century Swedish family life than you want to know. But there, the first child is somewhere between age 18 and age 23, and that's class-related. Wealthy men married younger women, and poorer men married women who had taken a little time to get together household goods, knew how to run a household. And notice that all of these societies stop much earlier. Menopause is an oddity among mammals, but humans are one of the species that does it. And they all start later. And then they cram the babies together. Okay? Now, sex differences in humans are not really extraordinary among mammals. Sex differences start with the fact that we are a sexually reproducing species, and we do so not by exchanging material, but by producing gametes. Now, when you produce gametes, you end up with only 2 sexes. If you exchanged material more than 2 mating types, if you were a slime mold, slime molds have 13 sexes, right? But if you have gametes, there are 2 kinds of selection that goes on. The first is, to be successful, you have to meet up with another gamete, right? And the second one is that the zygote you produce, the embryo, must be healthy and robust, okay? And it turns out that we have one of the very few cases of what's called disruptive selection, clearly in operation here. So who's going to first start with something like jellyfish, and they just dump their eggs into the sea? Which eggs get carried further? We don't even have tails on the sperm yet. Little or big? Which rolls downstream faster? Sand? Sand. So little gametes travel further almost by the physics of it to begin with. But who contributes the most to a large, robust offspring? The big ones. So it turns out that it's very difficult to be good at both things in the same individual. And so simultaneous hermaphrodites, individuals who produce sperm and eggs at the same time, they're very rare, and they're almost all sessile, sedentary organisms. Now, once you have anisogamy, here's the problem. You make little sperm, but they're round. And I make little sperm and put tails on them. There's a Gary Larson cartoon in which this little sperm has put an outboard motor on his tail, and the faster you get there, the better. So there's competition, and any trait, whether it's a physical trait like tail on the sperm, whether it's a behavioral trait, who would profit from cruising around and meeting a lot of individuals, a big gamete maker or a little gamete maker? Well, the point of making little gametes is to get them in warm, safe places. So it shouldn't surprise you that it's the sperm makers who are going to travel around and cruise. I mean, we all know females, all they have to do is stand there, right? The men will find them. So this is true across species. But there are some other things that happen. Mating effort, this cruising around, that's risky. You might run into diseases, you might end up in fights, you might fall off a cliff. So it turns out that mating effort, which is typical of the sperm makers, is high risk, and if you win, high gain, okay? So if you were going to do an absolutely classic species in which females only do parental effort and males only do mating effort, what you would get is, this is time here, and this is the percent surviving. Notice the males all die off faster than the females. That's a very, very classic survivorship curve for a polygynous species, where males don't bother with a lot of parental care, females don't bother with mating effort, okay? The other thing that's true is that for your investment, there's some amount of investment below which you have zero chance of having a successful offspring. Think first about parental effort, what we put into the offspring. So here's a point where you just have no chance, your child has no chance. Then over some range of effort that you spend, your child's chances increase and increase. At some point, this is the point that biologist Bob Trivers called parent-offspring conflict. At some point, even if you put more in, what happens to your child is unrelated to your investment. Okay, so you should quit then. And this is the time when even babies, species that are normally silent, will scream at this point. It's like, feed me or else, right? So what you find is that this is the return curve. What is your probable number of grandchildren as a function of your investment? There's really a whole family of curves that go everywhere between these two curves. But for mating effort, if you were a pure mating effort specialist, here's the problem. If you were something like a red deer, what's a red deer? Service. Okay. So to get any mating, if you're a male, you have to grow big. Now it takes you longer because it takes so much time to grow every kilo you add. So it takes you longer. You miss the chance to reproduce really early. But if you switch to trying to mate early, you just get beaten up by all the big males, right? So you have to take a long time to grow. Then you have to grow antlers, a huge cost. You have to learn how to fight. You have to fight for dominance. You have to hold a territory in many places. And all of that is to get your very first mating. There's another difference. Your second mating, if you're a male, costs you almost nothing. And your third mating costs you almost nothing. But if you're a female, you have to start this process all over again. So the male curve kind of looks like the female curve if it went way up there and then leveled out over here. All right? What this means is that it pays males and females in most mammal species to behave very differently. So it means that seahorse-like fathers, where the male takes care of the babies, they're rare. Women warriors, real women warriors, not symbolic, the queen holds a sword, but real women warriors are also rare because of these trade-offs. So most mammals, elephant seals are one of the best studied here. These are two males. No one would ever think these were females, right? You take one look at that, and it doesn't matter. I could show you frogs. I could show you seals, deer. You go, yeah, it's two males. They spend their effort on mating effort. Females spend their effort on parental effort. And that has some real implications. Here's the reproductive success of males and females at different ages. So what's the first thing you notice? Who starts earlier? Females, okay? And who goes on longer? Yeah. Now the shaded part is children weaned, okay? This is getting them successfully through to being weaned and independent. This is children given birth to. So you can see that female mammals, there's some learning to figure out how to protect your babies because males have these fights and they pay no attention to who's in the way. And in fact, most of the mortality most of the mortality of young elephant seals is little babies getting squished because the males are so busy galumphing across the sand to fight each other. But now, there's one other thing you should notice. This doesn't make it obvious that the scale is different there. The entire female graph fits under that line. So, being a female is relatively low risk and moderate return. And you pay so much per baby and you get a baby out of it. Being a male is like being in a tournament or a lottery. You will, of all male elephant seals born in the 25 years of this study, this is Bernie LeBoeuf and Joanne Reiter and some others, 83% of males died without ever getting a copulation. So guys, be glad you're human, okay? I mean, I'm serious. 4 out of 5 male elephant seals born die without getting a chance to reproduce, okay? What that means, at one level, is that since it's a very risky proposition, it's worth taking life-threatening risks to reproduce. If you don't take them, you will surely die. Okay? So what you get is risky behavior and conserving behavior. So what happens in traditional societies? It's true that there's enormous variation across cultures, but it's also true that there are very clear differences in strategies that work for men and strategies that work for women. Across every society that's been well documented, maybe there's an exception or two, but in general, for men, power or wealth, if it's a wealth-based society, many are not, and status are very important. In many societies, there are rules that if you are in this category, you may have 3 wives. If you are in this category, you may have only 1. Wealthy men, in many societies, your bride costs you real resources like cattle or sheep or money. And wealthy men can clearly marry, in the States we would say earlier and more often than others, okay? And women, it's interesting, the effect on fertility for women is a little more indirect. Let me first do a very general statement. It also matters what the resource base of the society is. So the black bars here are non-agriculturalists. They're like hunter-gatherers, sometimes called Swidden agriculturalists. This is the percent of societies with different total fertility rates. Total fertility rate is something demographers use, and it basically is if a woman lives throughout her entire reproductive life and at every age has the average number of children, how many children would she have? So you see it's always going to be a little high because some women do die and some children die. Okay, so this is not the same as realized reproduction. Once you have agriculture, what happens is many societies are able to have more children. So this is 9.5 or more children in a woman's lifetime. The Hutterites are up there. Down here, this is 3 to 3.5, 3 to 3.4. So there's a great range there. The Yanomamo are an egalitarian society, although that's a funny word. It doesn't mean that everybody gets equal treatment. Actually, among the Yanomamo, what matters most is, are you part of a powerful male group? If you have lots of tough male kin, you will probably do well. But it also matters that you be tough yourself. There's a category called unokai. It means that you have killed someone on a revenge raid. Now, this is not important in all Yanomamo groups. There's actually in the lowlands where there's high plant productivity and a lot to gain, this is a very common thing. In the highlands with lower plant productivity, people are a little more mellow about it. But in the lowland villages, here's what goes on. This is age, which I see didn't show up. Unokai number of wives at each age. This is 20 to 24, 25 to 29, 30 to 34, and 35 up. Okay? At all except this age, Unokai have more wives than non-Unokai. Over a lifetime, they have 5 children versus 1.5 children. So it pays to get out there and beat your chest and try to prove you're a really tough guy. The only age at which it's not significant, this actually is 1 here, right in the middle there. So non-Unokai men get to marry at about 30. But their Unokai brothers married in their early 20s and already have a kid. The Yomut Turkmen were the subject of a long study by Bill Irons. They're a market-based society, and it matters whether you're wealthy or not. I'm going to show you the men's data. This is the age of the men in Generation 1, and this is how many children are born to them. This is simple, who is wealthier than the median, who is less wealthy than the median. And you see that these curves are different. Now, the curves for women, the women who marry wealthier or poorer men, have the same shape, but they're not significantly different. They're like this. And you know, when I worked on the 19th century Swedes, this was also the case. It wasn't that, oh, if you're a daughter in a wealthy family, you're better nourished and you mature earlier. No. If you're a daughter in a wealthy family, you get married earlier to a wealthy man, and you start having children earlier. So it often is not significant. So across traditional societies, wealth and status matter to reproduction. They matter more for men than they do for women, and the particulars differ. Sometimes it's status, like unokai. Sometimes it's wealth. Sometimes it's both. Sometimes it's land. Okay? The particulars vary, but what matters is I have resources or I don't. For women, the difference is, you can think of it this way. For women, the variation is more at the low end of the spectrum. You don't have children, or you have 1 to 5 or 1 to 9 children. For men, the variation is skewed differently. So think about those elephant seals for a minute. 83% of them get 0 offspring. I should have told you at that moment, the biggest, toughest, fattest female elephant seal in that study had 10 offspring in her life. The toughest male had more than 90. Okay? So the pattern is different. The variance in male success is much greater than in female success. And that is true across traditional societies too. Now, if you want to hear the general stuff, Frank reminded me when he sort of said, and here's my book. Mine's older than his. You all know this already, but it's all summarized in there. Think for a moment about historical societies. These also vary greatly. I know less about other periods than I do about 19th century Sweden and Germany, for example. But they're an interesting link. I mean, I can tell you about Yanomamo, and you probably think, what does that have to do with how I run my life this weekend, right? In fact, one of my colleagues, this is great, one of my colleagues, Dick Alexander, who's now retired, used to run a class in which he, very early, much earlier than the rest of us, was teaching about this stuff. And he had as an assignment, every week you had to write a question, that had to do with the core material. And he got one week from a young man who said, so if you're right, and this is all about reproductive success, why am I sitting in your class instead of out on the campus looking for women? And I don't know that he had a good answer for that. Delayed gratification. But we're in a very strange, very weird, evolutionarily novel situation today. And to talk about traditional societies tells us some things, but the link is not clear. So historical societies give us another link, and the reason I chose Sweden was that instead of looking at what are called aggregate data, what did all the miners do, what did all the farmers do, I could actually link fathers, mothers, and children, and I could follow families through up to 5 generations. So mostly 19th century Sweden was agricultural with a little proto-industry, some cottage industry, small markets, very egalitarian. They had socialized medicine from the 1600s. Every village had a poorhouse so that if you lost your resources, you were fed, you could live. You weren't well off, but you could live. I did mainly two studies. Now, mostly I'll show you about this one of 9,000 people in 7 parishes, different economic bases. So this was a fishing village. These were agricultural. This was in the far north and had a huge infant mortality. Here's a woman's age at marriage. And this is the proportion of women who had no children at all. NBC is natural biological children. And no children alive at age 10. And you notice that if you start too young, it's costly, right? The proportion of women who don't manage to have children. But if you marry very late, of course, you're into lower fecundability and the failure rate is very high. We have known about this part for a very long time. Most people are now starting to pay attention to this early loss. But here's the other part. Women who married wealthy men, as I said, they married earlier. They had the same interbirth interval from birth of first child to birth of second child, and so forth. And they had the same, no significant difference in how old they were when they had their last child. But they got about 1.5 more children out of the fact that they began reproducing earlier. So this is the births per 100 women per year by age. So it's the age-specific fertility of women. And you can see that women who married wealthy men did better, had more children, had more surviving children too. This is a very complicated graph. I merely want to make the point that here are 4 parishes. This is the fishing parish. This is the reproductive value as calculated by Fisher. Okay, this is marriage, and this is births. So they were pretty good. They mostly waited until after marriage to have children. This one's interesting. They waited so long to get married in this parish. This is the one in the far north, and this is another, these are agricultural. These women married youngest. The peak was 20, okay? The peak here is 25, 26. That's a big difference. But this is a fishing parish. Some years the fish were great, some years they were awful. People waited a long time. If you ask then about fertility and actual number of children alive making it to age 10 within marriage, this parish had the highest. Really curious. So, here's this egalitarian society. They marry late. They've got social systems to protect them. Even so, here are daughters. Daughters of poor men were likelier to migrate. If there's an asterisk in there, there's a difference. And if more than half of them did something, it's a bold line. So if you were born to a poor father and you were a daughter, you were liable to leave the parish at age 15 or so. What were you doing? You were going to get work. Interestingly, Northern Europe in the 19th century, about half of adults never married. And in Sweden, it didn't matter. You notice you weren't more likely to get married if you were born to a rich family. The differences were really huge for men, though. Sons of poor men were liable to leave before they were 15, and they too were looking for work. They were going to work in other people's houses. If they stayed in the parish, sons of poor men were liable to be poor, and were liable not to get married, and liable to have no kids at all, right? The sons of wealthy, the pattern looks kind of like the women's pattern, but the worst thing to be was the son of a poor man. However, in the 9,324 people in this sample, there were about 24 about 24 sons of poor men who became wealthy. There were too few to do anything with statistically, but I can tell you they had 12, 13, 14 children. It was as if, I can tell a mover and shaker when I see one. So these were, again, high risk. You were most likely to be poor, never marry, never have children, but high gain if you could pull it off. So in historical societies, wealth and status, even in egalitarian ones, still mattered. The differences were greater for men than for women. And during the period I was working, Europe went through what we call the demographic transition, when family sizes fell from 8, 10, 12, down to 2, 3, 4. So let's take a break now, and when we come back, we'll look at modern societies, okay? We were coming down in the elevator a minute ago. Frank says, all right, all of that's fine. You can calculate for elephant seals and maybe for traditional societies what an optimizing strategy is. How do you manage to do that in modern societies? The short answer is, I don't know. I think that there are a number of difficulties, and modern societies are really weird. So our strategy has been a little different. We face evolutionary novelties today, right? We are ourselves sort of a horse of a different color, if you will. Our environments are extraordinarily novel. We live, so what is the population of Prague? 1 million, okay. Is that a single population in the sense that a biologist would talk about this population of elephant seals? Well, maybe in theory, but a population, when biologists look at other species, a population is a group of, individuals who live in the same place and are likely to interbreed. Well, do you each have the same chance, does each woman in this room as likely to meet and marry any one of the 500,000 men in all of Prague? No. So we have these large societies, and the way you live your life is not the same as the way the chancellor of the university lives his or her life, right? And it's certainly not the same as, say, a very poor young black woman in New York City lives her life. So we have multiple conditions, and in most developed nations, we have relatively late fertility. How old were you when you had your child? 24, okay. Now, that's late in the terms of human history. I know we've got a little background noise here, and I'm not sure what it is. So, there's another thing. If you were a Yanomamo man or woman, how likely you were to get pregnant. There were still social patterns, right? Marriage is a big deal in human societies. But then after that, it's sort of an ecological and subsequently physiological matter of whether you get pregnant and whether the pregnancy is successful and the child survives. There are lots of legal constraints. It took me a very long time to learn this. I'm very simple-minded, and I think it's like, okay, so, territoriality is like ownership. And a colleague of mine, a social scientist, well-known, said, no, it isn't. If an elephant seal dies, his territory is taken over by another male. I said, yeah, that's why they're the same. She says, yeah. But in human societies, we have third-party interventions. We have whole legal systems about who may take over that. So we have all this intervention in what was once mostly an ecological thing. Nonetheless, we should still find some classic patterns. Remember that graph I showed you in the first half where sort of your life expectancy and the relative age at first birth? Well, so we are, I'll come back to that in a second. We are running on patterns. There's some behavior, and we get a feeling from it. We call that a proximate cue. And this behavior also has some effect on our survivorship and reproduction, what evolutionary biologists would call ultimate relationships. And we're changing these and breaking these. So if you were living in the Pleistocene, there you would have what we call directional selection. Sweeter is better, okay? Eat the sweetest things you can find, because sweet things came in packages that we call fruits, and they came with vitamin C and fiber and so forth. So you put this directional selection for ever and ever on humans. Now I did this to my son when he was 7. I offered him and his friends, you can have an apple, great, healthy, sweet thing, or a Snickers bar, a kind of candy bar we have, right? Of course, you know how many apples I had left over? All of them. But the same thing is true about reproductive activity. In Frans de Waal's study of the chimps in the Arnhem Zoo, there was one female who hated males, had nothing to do with them, and it's true, she had no children. So in sort of past times, women have not always been able to avoid sex if they didn't want it, right? This is part of women in traditional societies having less choice. But if you liked it, you were more likely to have kids, right? Now we have birth control mechanisms, we break this, so that doesn't mean you don't like sex anymore, right? It means that we still run on these proximate cues, even when we've broken the biological effects they can have. So that's another big complication about looking at modern societies. So women's lives differ in all of these ways. And so trying to get a handle on this, how am I going to figure out what strategies work and what strategies don't work so well? So one of the things we did was to take existing data on fertility patterns, education patterns, work patterns, and survivorship patterns, and put them into a large model to compare them. So to back up, what I was going to tell you a minute ago was, given your life expectancy, you can predict what's the best time to begin reproducing. And you can do that for all kinds of species, and it's relatively straightforward. It depends on age-specific mortality, right? If you have high chance of dying, you shouldn't wait too long. And age-specific fertility. The bigger and older you are, the more you can do. So that's fine. It works for other species. If you do it for the Ache, you get about 17. You do it for the Kung, you get about 19. These are traditional societies. You try to do it for US whites, and you can't get a peak. You find that, yes, you can wait too long, and if you wait too long to start having children, but you get down to 12-year-old girls who have a child. The child doesn't die. The mother doesn't die. So we have this novel environment in which we no longer can say, tell me about the environment and I can tell you about the optimal biology. So this is very discouraging. On the other hand, we do know that humans, like every other organism, has to solve the same really basic problems of how to survive, how to reproduce, how to keep your family going. And we know from other species that age-specific fertility is influenced by adult mortality. Okay, that's that graph where the longer the life expectancy, the longer you can wait to start. So Martin Daly and Margot Wilson looked at, that says 3, it should be 30 Chicago neighborhoods in which they tried to control for socioeconomic status and all kinds of things like that. The big difference was in what we call extrinsic mortality, drive-by shootings. Okay, you probably don't know about this, but in large U.S. cities, you can be at risk just from being out on the street corner because occasionally somebody drives by and shoots everybody who's standing on the corner. It's very, very strange. So here's the 10 neighborhoods with the shortest life expectancy in green. This is the births per 1,000 women at different ages. So the early, high, peak. Here's the 10 neighborhoods with the median life expectancy, and then the 10 neighborhoods with the longest life expectancy. These data are exactly consistent with that graph I showed you that had warthogs and voles and ibex and so forth. Actually, I should do the calculation and put these 3 groups on there. So we do have, unexpectedly, these women are not thinking about this. Nobody's saying, life is dangerous, I'd better have a kid. Nobody's doing that. But it's interesting that you can make the prediction and test for it. So with colleagues, I've done 2 kinds of things. Some empirical, where we work with data called the panel study on income dynamics, where you can look at large numbers of people and you can track them through time, much like the Swedish data, except you don't have families. And secondly, a sort of model that uses data, but then allows you to put these different strategies in the same population, in quotes, and see who wins, see who continues. We do know several things. High adult mortality is associated, even in humans, even today, with early reproduction and less education. An early shift out of school into adult life and families. Education is associated with delayed age at first birth, and later ages at first birth are associated with lower lifetime fertility. And 2 ways. First, women who do have children have fewer children, and second, there's a higher proportion of women who don't have children. I mean, so here you are, right? How many of you who do not have children intend to have children? Not that many hands. Look at you. Want to have children. Want I'll count you twice. Okay, but you're in your mid-20s, and you don't have them yet. Okay, so here is age at first birth or age at marriage, first marriage, and here's lifetime fertility, okay? These are the empirical data. If you look at education and lifetime fertility for women, you see that this is the cost of education, okay? So you're in college now, most of you, yeah? Or anybody here in graduate school? Okay, so, these are US data, but I suspect you'll find the same pattern here. Now, here's women who have no children, okay? It's interesting that this is not quite linear, and it's a different set of causes. Here, it is that you wait, and then you end up with no children. Here there are women with disabilities who don't get a mate, may not be able to have children. There are more physiological problems, and this is more a social education issue. In the United States, women have changed the patterns. So these are data from a woman named Kristen Luker, and she took 1976 age-specific fertility, sort of by age, compared to 76, 1982, 84, 86, and 88. Basically, what you find is that women increased their fertility, but it was more compressed. More women had children in their 30s, and they stopped having children after 40. Interesting, right? Birth control makes a lot of things possible. So my oldest Swedish mother, my old woman with the last birth, she was 54 when she had her last child. You have to have a lot of energy to pull that off. So we're a little strange here because low fertility in other species is associated with late maturation and high investment only when it's profitable in that environment. Okay? So what we've got here, this actually, people who work on life history absolutely hate it when you talk about R and K selection. And I don't like it, and I'll talk about it in the questions if you want. But here's what we saw before. Get big, get resources, make a lot of babies. There's no differential mortality with your investment. Your survivorship, your children grow up, have kids. We've switched. The variation in modern societies is not here. You have 1, 2, 3 children, 5 in the back there, but you don't have 10 or 12. Much more variation is seen in how much you invest per kid. In the United States, it takes you much more to go to Harvard than it takes you to go to the community college, right? And this is not subsidized or supported. So it's a big difference, okay? So we have shifted from all the variation being in number of kids. Now, we're having fewer children. We're investing more in them. It might make sense, I thought originally, and you might think, it might make sense for women to follow not a high fertility strategy, but a mixed strategy. You know, gather some resources so that you, as a couple, as a family, you are better able to invest. So I wanted to find out whether this worked, whether this would be adaptive. But it's hard to do it with empirical data. Really hard to get income data and fertility data and get them on a cross-section. So the question is this circle here, is that adaptive or not? You have fewer than 10% women in the parliament. We have, this may have changed since last year, 87 men in the US Senate who have 3 children on average each, and 13 women who have less than 1. Be really neat to find out about the women in Parliament, how many have children and how many children they have. You might not have such a difference as we have. I'd really like to know. Way back in the beginning, I said that I thought women had a harsher trade-off than did men for investing in self versus investing in children. Like the women senators, if you look at the 50 most powerful, Fortune magazine does this study every 5 years. They go, who are the 50 most powerful women in U.S. business? And I've been looking at the fertility of these women. Now, it's hard to find those data. So far, I know for sure that 3 of the 50 have children. How many of the 50 most powerful men in U.S. business do you think have children? Yeah, interesting. So I think that modern women have a real set of trade-offs. So I made a model. Actually, I got somebody who's better at this kind of modeling than I am to help. So here's the kind of thing a woman faces. She's born. So she has some initial, you get 1 for existing. She goes to school. She could die. I didn't put it in here, but at any moment you could die, or you could get older, you could go to school. At some point you could keep on going to school, in which case it costs you right now, but you'll make more money later. You could stop school earlier and work, and you get more money now, but you may always be stuck, in this low-paying job. Or you could stop and have a child, in which case it probably costs you in money. So at any moment, you might face these from the time you're 12, 13, middle school we call it in the US. What do you call it here? Secondary school. Okay, from secondary school on, a woman could do any of these 3 things, but most of the time she can't do 2 of them or 3 of them at once. Okay? So we made a model. We have 9 socioeconomic strata. We have 2 levels of what we call social capital. I'm only going to talk about 1 here. Social capital is, do you have a support system? Do you have a family? Is your family intact? I'm going to talk about intact families here. I'm not going to add what we might get if you're a child of a single parent with a lot of stress. So we start these women out, and we have 7 age classes. I lump everybody who's 45 and older, because they'll die someday and they won't have any more kids. It's very ageist of me. And we have 5 levels of education. Now here, you must keep this in mind, because the results we get are even worse than they look, because in this model, even if you don't start to have children until you're 35, you still have 1.05 daughters. In other words, you have the same number of children in this model no matter when you have them. Now that's unrealistic, okay? Now this is a woman at some state. You'll see numbers in the model I show you. And this, don't worry about them. They just code for her age, her social capital status, her education, her socioeconomic, and whether she has a child or not. And what we did was just dig and dig and dig in the sociology literature and the education literature and so forth for what is the probability of, if you're in this state, going to this one or this one or this one. And so we use these transition probabilities. Now, this is one socioeconomic stratum, and here a girl is born. She gets older. She could go right across here, right? She could stop school with elementary school and just get older and never have a kid. Or she could go to school. This is elementary school, secondary school, gymnasium, college, graduate school. If she has a child, she bounces down here. Now, that's a bit messy. So here's a girl who, this should be green, who goes to elementary school and has a baby. Boom, right? Here's another girl. She dropped out of high school and had a baby. Here's another girl who goes through college and then has a baby. Okay? Now, we're putting 1,000 women into each of the socioeconomic strata, and then they, by chance, will die, get older, stay in school, have a child, or work. Here's the whole model. There are 9 socioeconomic strata and 5 educational and 7 ages. 7 ages, 5 education categories, child or no child, and you go from poor to wealthy. Now, I said we estimated the transition probabilities from the literature. Some of these are very likely. If you're down here and very poor, you are far less likely to go to college and graduate school and then have a child, okay? If you're wealthier, you're more likely to complete your education before you have a child. Does this make sense? Are you with me? This is, I know it's complex. Maybe this, here's a likely transition, right? You're in an intact family, and here you are, you're a girl who manages to stay in high school. What that does is propel you from the poor, level 3, which still has high mortality probabilities, into category 4, where you're likelier to have children a little later and have them live longer. Here's a very unlikely transition, right? Sort of, you're the household maid in your stepmother's house, and you marry Prince Charming and have an intact family and live happily ever after. So that's the least likely one. So we ran this model. And what I was hoping was that women, like the women in this room, would sort of do pretty well. That trading off. There's a New Yorkism, it goes, forget about it. So in other species, you see low fertility in 2 conditions. One, when you're starving to death, which isn't very interesting. And the other, when you have to make a super baby to have any success. And that's not so interesting. So the most interesting thing that came out of this model was that women in the very poor socioeconomic classes who managed to stay in school through high school did better. Their lineages continued, okay? The very poor, these women, now, in the real world, they might have more children than in our model, okay? But the very poor women had high child mortality, so they didn't have long lineages, great-great-grandchildren, The other group who essentially disappeared on us was the women in this room. Try not to wait until you're after 30 to have children, okay? So there's still one more possibility, right? I'm desperate now. I got to make something come out of this. So maybe having resources, even though your lineage is not growing, maybe it will protect you if a resource crunch comes. Okay? So maybe the wealthy are more protected than the poor when things get very tight. Okay? So this turns out to be theoretically very difficult to deal with because there are 2 kinds of models that people use. One takes age structure into account, and we definitely want that. We need to know age structure because we want age-specific fertility. But it assumes a growth rate that's constant, and it assumes that your probability of going from age 1 to age 2 is the same, whether the population is really crunched or very low, okay? So that's not great. Then there are the Lotka-Volterra logistic, dn dt equals little r n k minus n over k. You all had that in freshman biology. You don't need to know about it, but it does slow a population growth down as you reach some resource capacity, okay? But it doesn't let you look at the age structure. So we're like, what are we going to do? Fortunately, I'm married to a mathematician. So we want the advantages of both of these kinds of models. And so what we are able to do, we used a little, I'm going to add some assumptions, and then we used a little trick of an exponent to help us slow the different subpopulations down at different rates. So the wealthiest, the socioeconomic status 9, consumes 15 times as much per person as socioeconomic status 1 does. So if you wanted to say, what's the carrying capacity, and you have a fake world with some amount of calories in it, it's different depending on the composition of the population. There's an interesting book. It's 10 years old now, but it was by a guy named Joel Cohen, and the title was, How many people can the Earth support? Book's this thick, goes all the way through all the things you have to think about, and the bottom line answer is, it depends. And the reason is that it depends on whether you want to assume resources are equally distributed, whether you're willing to have a wealthy versus poor, and whether, who gets theirs first. So that's part of what this model is going to do. So we're going to use an exponent to slow down growth. So here's this, dNdt, that's the percent growth rate. And what we've done is we've added a little exponent. If we don't put the exponent in, it looks like the yellow curve. And different exponents will slow this down. Now think about this for a minute. What difference, if any, will it make if the wealthy do this and the poor do that, or the poor do this and the wealthy do that? So that was the question. I'm desperate here trying to say, maybe women continuing can be protective. So this is what we call the zero population growth response. This is how close is the population to carrying capacity. Here the environment is full. ZPG response says, I'm never going to make more children no matter what. Here's the standard model. And then if you put an exponent of 100 in, it'll go way up there. And the population can keep going and going, but I am going to keep having children if I have this exponent, as though the environment were open. Okay? So subpopulations with this exponent, with these exponents, the high ones, they get an advantage. As the world gets fuller and fuller, subpopulations like this slow down, whereas these keep putting children out there. So they get their cut first. Okay? Well, I hate to tell you, it didn't make enough difference. So I'm going to talk about population and wealth. Okay? This is the poor. This is socioeconomic status 1, 2, 3, 4, 5, 6, 7, 8, and 9. Okay? So the poor to the wealthy. If the wealthy are protected, they still decrease. The upper middle class isn't much hurt. The lower middle class, these are just my terms. In the United States, you can't use these terms. Although, do not be tricked into thinking the United States has no classes. Okay? We just don't talk about it. The poor decrease, even when what you're doing is letting them not be hurt by the resource constriction. And even though they have high child mortality. Now, they decrease even more, the wealth, it's just hopeless. So it makes very little difference. Here's where it makes a difference. When the poor are protected, people who are struggling can do better. They get to make it from socioeconomic strata 3 to 4 or 4 to 5. And that's about all that came out of this model. If you looked at, I used to show a graph, but I got too depressed, of, after 1,000 generations, what proportion of the population had early foundresses and late foundresses. And my group went extinct, so I don't want to show that anymore. So, what's the point of this? I am not proposing that everybody stop and have babies. That's not my... One of the nice things about being human is that you can make the decisions of your life independent of what they might mean to some biologist somewhere, okay? I have nothing whatsoever to say about whether, having a child is good for you or not. Nothing. What I do think is that for people who are interested in making policy, there are some environments in which it is easier for women to combine education, work, and fertility. And there are other environments in which it's more difficult for women to combine those things. And I think that if we thought about that, we might be able to make better policy, okay? I have a couple of examples. These are from my students' work where maybe well-intentioned policy has had unintended consequences on fertility. Here's the work of Stephanie Hitztaler, and I can also give you, I have some PDFs of the papers this talk is based on, and I put them on this computer, so you're welcome to those. But I realized I didn't put some other papers on. I'll put those on. So Stephanie Hitztaler worked in the Kamchatkan Peninsula. She worked in a set of villages in the central sort of depression. These were forestry villages, and throughout the Soviet time, forestry was subsidized. With the Soviet collapse, that subsidy disappeared. So what happened? Here are births and deaths in 2 of these villages. Notice that right after the collapse, birth rates plunge, death rates go up. Demographers are interested when lines cross like that. I mean, that really means everybody's dying, nobody's having kids. It's a quite dramatic shift. And so here's the net sort of change in people due to those births and deaths. It varies by village. It's not exactly the same. In all of the villages she studied, birth rates went down, death rates went up, and out-migration increased. That's true in all of them. But in some cases, it was early. In others, it was late. Why? It had to do with how the forest existed. That is, in some areas, the really easy-to-cut forest had all been taken off, and people were already having to go up the mountain, and it was hard. So the collapse in fertility and the out-migration happened earlier in villages like that. So bottom line is 2 things. One, they all showed population declines, decreasing fertility, increasing mortality, increasing out-migration. But 2, the general pattern differed depending on specifics. In Mao's China, Tifen Ting compared an urban province, a very poor rural province, and a better off rural province. Now this one, you could spend a lifetime on. Don't worry. These are different. This is the Great Leap Forward, what they call they figured out that everything was going to hell in a bucket, so to speak. This was called rest and recovery, where some of the constraints were relaxed. This is the Cultural Revolution first phase, Cultural Revolution second phase. This is post-Mao, and this is the one-child policy. Notice that the one-child policy in no way had the biggest impact on births. This is births per 1,000 women. Great leap forward, huge problems. You look at this, and there was not the intent until the one-child policy to cause a great decline in fertility. But policy did. The policies were intended for other ends. Here's deaths per 1,000. The only bump that is not due, this is actually an earthquake in Hebei. That's the only bump on there that's not a political bump. And this is sort of the net effect. And you can see that the red is Shanghai, the urban one, and the other two are the rural ones. There's a sort of difference. I don't have time. I'll be happy to talk in the questions about this. But bottom line, the only thing you really need to remember is policy intended for social and political reasons can nonetheless have reproductive effects. So I did one other thing. I'm going to run 2 minutes over, Frank. Sorry. So China's one-child policy actually is interesting in and of itself. There's this long, long history of preferring sons. It's better to have geese than girls. When the one-child policy was implemented, there was not an effect in first births, because the big effects came later. So here is how many brothers and how many sisters you have. This is you have no brothers and no sisters. So the sex ratio at birth there is very, very faintly, it's about even. It's about 100, 106. If you have 3 brothers and no sisters, you are hugely, if the parents have 3 sons and no daughters, the 4th birth is enormously likely to be a daughter. If you have 3 daughters already and no sons, you are more than twice as likely to have a son. Now it's interesting, this varies also urban, rural, because the technology for amniocentesis, for telling the sex of your child, that's in the cities, but the son preference is not so strong in cities. So, some things haven't changed much in the modern world. It's true that in most systems, resource constraints lower fertility, and wealth and access to mating are liable to be correlated, and women, whether you're talking about traditional societies or modern societies, face a harsher trade-off in what you spend to get resources for yourself and what you spend on your children. Some things have changed a lot. The variation in family size and sheer numbers has decreased greatly. We have effects on fertility that started out not intended to have anything to do with fertility. So, if you were a hunter-gatherer in the Pleistocene, what happened halfway around the world meant nothing to you.